Hello guys, in this video I'm making mains voltage powered LED panel that I'm using for UV exposing different chemicals. Be very careful when you're working with mains voltage, it's deadly. The circuit I started with, I made this capacitor dropper circuit a few years ago and it was working perfectly. So I basically copied to this circuit. And I made a PCB and I ordered everything, and the circuit was not working. This one has 2.2 microfarad capacitors as a capacitor dropper, and 200 the rectifier bridge diode, and 220 microfarad capacitor for smoothing out the voltages. And here I made a fatal mistake. I put plain fuse instead of the current limiting resistor, and that's why my circuit pulled maximum current as soon as I plugged it in and just everything burned. My original idea was to have 120 milliamps running through the circuit, and that would be divided to 6 strings by 20 milliamps. So finally I came up with this circuit over here. This one has 1 microfarad capacitor, has two 680 power resistors, and two 1 meg resistors just to reducing the voltage and draining the capacitors after the circuit is switched off. So I have these 3 strings of 16 UV diodes. They're not white because in LT Spice I couldn't find any diode with this was the only diode with 3.3 volt voltage drop. And in this circuit I would have 60 milliamps running through the circuit, and that would be passing through 330 ohms current limiting resistors, and altogether I would have 20 milliamps running through the 3 LED strings. So if I test this in LT Spice, if I test this line, you can see that I have approximately 60 volts, 57.9 volts on that line. And if I test this part of a circuit before last diode, you will see that I will have exactly about 3.3 volts. That's the same as the drop on the diode. And through the resistors I would have 18.28 milliamps. So let's go to KiCad and check how did I make this PCB. And basically it's the same circuit. As you can see, everything's the same except I put this small fuse over here. This schematic is very simple and there's nothing much more to say about it. But the bottom part, you can see a lot of connectors on the bottom part of the schematic, and I will explain to you. It will be clear in a minute. So the thing is, exposure area. So the total panel size that I needed was about 300 millimeters by 200 millimeters, and I didn't want to order that big PCB because it's it's expensive and it is it's more complicated. So my idea was to make a panel and connect 9 different panels into one big panel, approximately of the size I already said, 300 by 200 millimeters. And so I drew in a CAD program, I drew a panel that is approximately 1/9 of the size of the panel I needed. And so this is this big rectangle that you see. Then I placed small rectangles. These are LED diodes, so that they are all 11 millimeters away from each other. And these 11 millimeters I got by testing and measuring the exposure that I needed from each LED diode and the distance. So when I put all panels together like this, all 9 of them, I got area about 264 millimeters by 200 millimeters, and that's good enough. And as you can see, all LED diodes, even LED diodes from this panel to a neighboring panel, are also 11 millimeters away from each other. And then I needed 3 I needed 4 mounting holes, and basically that's it. So when I made this part in a KiCad, and when I developed my board, I just placed mains voltage on top layer, and on the bottom layer of the blue layer you can see the rest of the circuit. These big copper pads that you see here is copper pads for resistors, 2 power resistors, and so I put like 2 big copper pads so they will have some power heat dissipation. I'm not sure. I don't think that's needed, but just well, if I can do it, I will do it. So also, as you can see here, I have 8 connections for live and neutral for mains voltage, and these connections will solder directly from this board to the next board. So I will be connecting only 2 wires from this live or neutral or wherever it is, and then the rest of the mains voltage will just pass from board to board, and I will solder a wire directly to interconnect two boards together. So if we go in 3D viewer, and you can see this, you can see these features. So we have these 8 connectors all marked with this red high voltage triangles, and I put also 2 test points so I can test the voltages and stuff like that while the circuit is alive. These pads on the corners are not connected to any net, and well, I just placed this in case that I needed some additional rigidity. I can solder strips. I can solder nickel or copper strips here, connecting from one board to another, just to keep them rigid and solid next to each other. So this is the first version of board I made. One that I made a mistake not putting a resistor, current limiting resistor over here. So the first version of the board I put together, it burned straight away. Basically it was the same as the version you saw in KiCad. The only thing was there were 6 string of diode. So when I realized that was a mistake, I just like breadboarded one from the pieces I had at home. So these are 2 power resistors I put instead of the fuse, and so I soldered them directly to a bridge rectifier over here. And then I bought together 2, I don't know, can you see it, 2 0.47 microfarad capacitors, and also on the bottom side I had to like put these bodge wires in order to have everything connected. I'm sorry, I cannot fit this into one screen over here. And this board was working perfectly. So this is the final version of the board I made. As you can see, these 2, now we have 2 power resistors over here, and they are, I don't know, can you see it from reflection, they are soldered onto 2 big pieces of copper pour. So for heat dissipation, this is also a fuse I put, and the rest is more or less the same. On the bottom side you have 2 pins for capacitor protruding outside, and I will need to put something on it just for safety, because I plan to put everything into a case. And so then on top side of a board, when I put them next to each other, they will connect 220 from one board, 220 volts from one board to another over these steps over here. And I plan to have all 9 of them, and after that I'll make a case. So let's go ahead and put some solder over here, and I will solder in front of camera complete. I will put together one complete board. Okay, place this under a microscope just so you can see how the solder paste is placed on pads, and I use a fine nozzle with it and the syringe, and there's nothing complicated to it. You just need to hit the pad and put enough solder so the LED diode will stick. the quantity is not, you don't have to be perfect. You just need to place this on every pad, and that's the problem with this much pads. You always forget something, so this is better, much better and faster done with the soldering stencil, but in this case I don't need it. I'm doing just few boards. Yeah, with everything, with all solder paste dispense, I just place the components with my vacuum pick and place pen, and that's very simple, especially when the components are this big and all facing the same way. So basically you just do this in a minute. So when all LEDs are placed now, and I need to place these 3 current limiting resistors, and after that it just goes straight into the oven. This is LED solder, so I'm using LED solder program on my cheap reflow oven. So if you look carefully in this part of the video, you can see that the solder flux is boiling underneath the LED component. I need LEDs, and this program lasts only to 5.5 minutes, and everything is done perfectly. But every first board you do in the oven, you need to check, especially these boards with white solder resist on them, because they're very sensitive to heat. But well, looks good enough for me, and I will just place this under a microscope after this, and the other side looks good. Nothing was cracked or damaged, so the temperature was not too hot. And under a microscope everything looks fine also. It's not perfect, but yeah, it's good enough for this purpose. And I will just test one LED diode with the tweezers, just to be sure. Okay, now the bottom side of the board is completed, and now I will solder the top part. I will combine soldering with the hot air gun and soldering iron, but first I will put some solder paste on these tabs. You can do this without solder paste. You can just put some solder on one of the tab and then solder just with the soldering iron. But this way is much faster. I will do it like this. So some more on the resistors. And this one and this one, and I'll put some on the fuse like this. Okay, so let's populate the board. Okay, the bridge rectifier, that's the easiest part. So it's, I don't know, can you see it? It's marked very well, so it's very easy to recognize what pin goes where. It's very hard to do this over the camera. So the next thing I need to place are these big resistors. So I will use my, it's hard to do this on the camera, so I need just 2 of them, and I'll use my okay, this is it, and then okay, that's it. replace the fuse now. Okay. After the fuse I will place this capacitor just by hand, and that's it. And I will start first with this resistor. I don't know, can you see it? Is there enough light? It's hard to do this over a camera. Yeah, you can see that this one is soldered right now. So I will go through the same process for these 3 resistors. So this one, and then I will heat some of these also. And then I'll just focus heat on this one. I think I cannot see it on the camera, but this one is okay. So I will heat these 3. I will just a bit preheat them, and then I will focus my heat on one of them. Okay. And then I have this one. This one's okay. And then I need to do this one, and this is fine. So the next thing I need to do is a bridge rectifier. So I'll just focus my heat on one of these, and I'll do the rest with the soldering station. It's going fine. And then I'll do the other side. Okay. And this side's fine. And with the capacitor, it's too big. This is too big to heat it up properly. So I will do it with a soldering station. So you just need to touch it and hold it up a little bit. So this side is soldered, and then we will repeat the process with another side. You just need to press it down and touch the tab, and that's it. Yeah, I think this is fine. Okay, and then the last thing we need to do is to place the capacitor. I will turn this other way around. And then I just place a little bit. Oof, it's very hard to do it on the camera. I'll do it like this. And then I'll press it down until it soaks in, and I think this is fine. Yeah, let me just check on the bottom side. Yeah, this is it. I'll clean my tip, and then I will just bring over the heat. And I think this is it. I don't want too much solder over here because I want to cut it as short as possible. So then I'll take my side cutters and I'll cut one pin off, and I'll cut another pin off. Yeah. So basically this is the board completed. So the next thing I need to do, I need to solder two wires here and over here so I can test it on 220 volts. Okay, so this is the last part of a circuit. I need to just solder some wires over here to contact, so I will put some solder over here, and then I'll try to solder a wire over there. One wire there, and another one over here. I've got my board set up over here, and I switched on one light. I will. This is plugged into. This is plugged into a cable, and I put everything on a plastic board just in case something goes horribly wrong. I will plug this part here now into a mains voltage and see are the LED diodes coming on. Yeah, I don't know, can you see it on camera? I will switch off these lights. They're pretty bright. But a lot of these, lot of the light coming off from the LED diodes are in the UV spectrum. So, so these are working. Let me just plug this off, and I will turn this board around. I will bring in the multimeter and try to check. I don't know, can you see it? And try to check some voltages. Yeah, I'll do it like this. I believe that this part is alive, still a lot of voltage, yeah, over 30 volts over there. I will plug the same circuit back in, and let me just put it on a side like this. I will plug it back again, and I will check some voltages again. Yeah, so this should be about 58 volts over here, and it is 59, it's close enough. And this part over here, these two tabs are live, so I wouldn't be touching this. Yeah, they're 240 volts. So the circuit seems to be working, and the next thing I'll do, let me just plug this off. The next thing I'll do, I will assemble all 9 boards, and I will make a case for it, and I will put that into another video. So thank you guys for watching. If you like this project, give me a thumbs up. Thanks.